Hello everyone, welcome back to my channel. I am Vamshik Shetty, pursuing third year B in Sri Venkateshwara College of Engineering, Bangalore. Today in this video, we are going to discuss about the one of the major topic in the computer graphics, that is circle generating algorithm. Now let us get visual with our process. Today in this video, we are going to discuss about the introduction on the circle generating algorithm and some of the properties of the circle, and one of the major algorithm in the circle generating algorithm, that is midpoint circle algorithm. And we are going to discuss about the one of the example based on the midpoint circle algorithm. Now let us discuss about the basic introduction on the circle generating algorithm, that is midpoint circle algorithm. The midpoint circle algorithm generates all the points on the circle centered at the origin by incrementing all the way around the circle. The strategy is to select which of the two pixels is closer to the circle by evaluating a function at the midpoint between the two pixels. To apply the midpoint method, we define the circle function as function of x comma y is equals to x square plus y square minus r square, where r is the radius of the circle. To summarize, the relative position of the any point x comma y can be determined by the checking the sign of the circle function as follows. If function of x comma y is defined as, if x comma y is inside the circle boundary, it is lesser than 0. If x comma y is on the circle boundary, it is equals to 0. And if x comma y is outside the circle boundary, then it is defined as greater than 0. This is about the introduction about the circle generating algorithm. Now let us discuss about the properties of the circle. A circle is defined as the set of points that are all at a given distance r from the center position xc comma yc. For any circle point x comma y, this distance relationship is expressed by the Pythagorean theorem in the Cartesian coordinates as x minus xc whole square plus y minus yc whole square is equals to r square. We could use this equation to calculate the position of points on the circle circumference by stepping along the x-axis in unit steps from the xc minus r to the xc plus r, and calculating the corresponding y values at the each position as by the below formula y is equals to yc plus or minus root of r square minus xc minus x whole square. One problem with this approach is that it involves the considerable computation at each step. Moreover, the spacing between the plotted pixel position is not uniform. This is about the sum of the properties. Now let us discuss about the some more properties of the circle. We could adjust the spacing by interchanging the x and y, stepping through the y values and calculating the x values. Whenever the absolute value of the slope of the circle is greater than 1, but this simply increases the computation and the processing required by the algorithm. Another way to eliminate the unequal spacing is to calculate the points along the circle boundary using the polar coordinates r and theta. Expressing the circle equation in parametric polar form yields the pair of the equation. X is equals to xc plus r cos theta, y is equals to yc plus r sin theta. This is the representation of the circle in the polar form. This is about the properties of the circle. Now let us discuss about the midpoint circle algorithm. This algorithm is used to help to generate the circle. Input radius r and the circle center xc comma yc, then set the coordinates for the first point on the circumference of the circle centered on the origin as x naught comma y naught is equals to 0 comma r. Now this is the basic syntax, and calculate the initial value of the decision parameter as p naught is equals to 1 minus r. At each xk position starting at k is equals to 0, perform the following test. If pk is less than 0, the next point algorithm centered on 0, 0 is xk plus 1 yk, and pk plus 1 is equals to pk plus 2 k plus 1 plus 1. Otherwise, the next point algorithm circle is xk plus 1 yk minus 1, and pk plus 1 is equals to pk plus 2k plus 1 plus 1 minus 2yk plus 1, where 2k plus 1 is represented as 2k plus 2 and 2yk plus 1 is represented as 2yk minus 2. Determine the symmetry position points in the other 7 octants. Move each calculated pixel position x comma y onto the circular path centered at xc comma yc and plot the coordinate values as follows, where x is equals to x plus xc, y is equals to y plus yc. Repeat the steps, all the 3 steps through 5 until x greater than or equals to y. This is about the midpoint circle algorithm. Now let us discuss about the midpoint circle algorithm using the one of the example. In this example, we have taken the circle with the radius 10. We demonstrate the midpoint circle algorithm by determining the position along the circle of 10 in the first quadrant from x0 x is equals to 0 to x is equals to y. The initial value of the decision parameter is p0 is equals to 1 minus r, where r is the 10, r value is equals to 10, so 1 minus 10 is equals to minus 9. For the circle centered on the coordinate origin, the initial point is x0, y0, where the x0 value is 0 and y0 value is 10. And the initial increment terms for calculating the decision parameters as 2x0 is equals to 0 and 2y0 is equals to 10, where 2 into 10 is equals to 20. Successive midpoint decision parameter values and the corresponding coordinate positions along the circular path are listed in the following table. So this is the table which we obtain based on the midpoint circle algorithm, where when the decision parameter is in the negative value, then we are going to increment both the xk plus 1 and the yk plus 1, and the corresponding 2k plus 1 and the 2yk plus 1 is calculated. And if the decision parameter the pk is in the positive value, then we are going to increment the xk plus 1 and we are going to decrement the yk plus 1. So in the first iteration, we can see that the pk value is minus 9. So we are going to increment the both the xk plus 1 as 1 and yk plus 1. And the yk plus 1 is remains constant. And the corresponding 2k plus 1 and the 2yk plus 1 is calculated. If the decision parameter here, in the fourth iteration, we can see that the decision parameter value is 6. So it's in the positive value. So we are going to calculate the we are going to increment the xk plus 1 and we are going to decrement the yk plus 1. Here the 3 is incremented as 4 and 10 is decremented as 9, and the corresponding 2k plus 1 and the 2yk plus 1 is calculated. So this calculation goes on and correspond a plot and in the with this calculation goes on, and we are going to complete this process in the first quadrant, and the by these corresponding values we are going to generate the or plot the graph using the pixel position in the first quadrant is shown in the figure. In this figure, we can see that the graph has been plotted using the corresponding values. This graph is plotted where the circle half of the circle is the circle is generated using the first quadrant in the same way we are going to uh, get the corresponding values in all the quadrants, so we are going to get the complete circle. This is about the midpoint circle algorithm. Now let us discuss about the midpoint circle algorithm using the code. This is the midpoint circle algorithm where we are going to implement the midpoint circle algorithm using the Python code. Here we are going to first import the pygame and the import system. First we are going to we have used the function to draw a pixel at the center points, that is using by defining the draw pixel, and we are going to define the function to plot the pixel in all the eight octants. We have used the define function plot pixels to define all the eight octants, and then we have used the circle draw to implement the midpoint circle algorithm, and we have used the main function to calculate all the functions which we have used, that is the draw pixel and the plot pixel and the circle draw within the main function. And we have set up the display by using the pygame and background color, and we are going to draw circle by using the circle draw, and we are going to refresh the display by using the pygame display, and we are going to exit the display by the uh, while loop. This is about the code by user which we have implemented for the midpoint circle algorithm. Now let us check this code how it is going to work. Yeah, this is the output that is generated by the midpoint circle algorithm. We have displayed the we have got the window display of 800 600 in width and height with the title of the midpoint circle algorithm. In the center, we have seen the circle has been generated by using the all the points which we have implemented in the code. This is the basic circle generated by using the midpoint circle algorithm. So this is the output that is generated by the circle algorithm. Yeah, this is the code. Yeah, we are done for this video. So thank you for participating and have a great day ahead. So thank you. For more videos, please like, share, and subscribe the channel. Thank you.